Good afternoon, everyone. Welcome to this informational session about the Department of Aerospace Engineering and Mechanics and the Bachelor of Aerospace Engineering Mechanics major. My name is Johannes Ketema. I am the Director of Undergraduate Studies at AEM. I also have with me 4 students who will introduce themselves and talk about their experiences at our department later on. So I'll start by telling you a little bit about our program. So I'll start with an outline about, so what we'll do is talk about what aerospace engineering is. We'll talk about the major employers who hire our graduates. And then we'll talk about, what it's like to be an aerospace engineering student, student groups, hands-on activities, and so on. And then we'll have a panel discussion where the current students will be speaking. So what is aerospace engineering? So there are 2 kind of major parts in aerospace engineering. One is what is called aeronautics. That's basically then about atmospheric flight, airplanes, helicopters, drones, and so on. And then there's also the space applications or space flight or astronautics. And this is where you study about how to, for example, send spacecraft that will be satellites orbiting our Earth, or it could be spacecraft that are sent out to another planet, let's say Mars or Venus, and so on. And so all of this then is part of aerospace engineering. So in order to be able to kind of work in this area, there are 3 major kind of topics or sets of courses that you would take within the major. I'll talk a little bit more about each of these, but so first we have fluid mechanics or aerodynamics, which is about the flow of fluids around bodies typically. And then there's structures and materials, because you need to learn about what materials to use in building your airplane or spacecraft. And then there's system dynamics. This is generally about how to control the motion of bodies. And then, of course, possibly airplanes or spacecraft again. So talking about fluid mechanics, and aerodynamics is kind of a part or a special case of fluid mechanics. What it's about then is that you want to understand the effect of the flow of air around bodies, typically your airplane. And so what types of forces are generated when the air is flowing around the body, or in real life, it's the airplane that is flowing or moving through the air. And as you may have already seen, the flow of air around a kind of specially shaped body called an airfoil, which is typically the cross-section of an airplane wing, will generate several forces. There's a lift force that is actually lifting the airplane up. There's what's called drag, that is resisting the motion of the airplane. And there's a moment that tends to turn the body in the counterclockwise direction, the way we're looking at it. And so it's important to understand all of these. And this is kind of the main goal then in studying fluid mechanics and aerodynamics in the context of aerospace engineering. There's also other kind of extensions, we might say, of aerodynamics, and that is propulsion, where in addition to just the flow of air, there is also other things going on, such as combustion of the of fuel in the air, right? And that the exhaust then flowing through the jet engine or out of the jet engine is what is causing the force on the airplane in the other direction. So this would be a jet engine, but of course there are many other types of um, engines, and including rocket engines, that are all important then as a means of creating propulsion, which also will be studying. The next area that I mentioned is aerospace structures. And again, this is about the materials that we use, but also how to put them together into structures that have the characteristics that we want. So for example, the right stiffness that you want, or vibrational characteristics that you want, and so on. So this is generally called structural analysis. And there's a lot of software that is used to analyze these types of structures. Lastly, we have system dynamics generally, but in particular flight dynamics and control when we're talking about atmospheric flight. And as you know, the way airplanes are controlled, or the way the motions of airplanes are controlled, is through the use of what are called the control surfaces. So for example, we have the rudder, there's what's called the elevator, and these are control surfaces that can be deflected to cause the right amount of moments that we need to turn the airplane in the right direction. So kind of a high level view of how all of that might work might look something like this, where we have a pilot, say, sending a command to a flight computer, and then the flight computer sending a command to what is called an actuator, a type of motor that is attached to a control surface that is able to deflect that control surface. So because of that deflection, then the airplane will move in a certain way, maybe turn in a certain way, and that is picked up by sensors that tell the flight computer how things are going in terms of doing that maneuver. And then the addition, that order that was sent may be adjusted to either continue along that same line or to reduce the deflection and so on. So this is a control system, and control systems are important whether you're dealing with airplanes or spacecraft. And so in the area of system dynamics, you learn about how to analyze the motion of aircraft, and also how to control the motion of aircraft. Another area that is also related to system dynamics, which is an application of just the general area of dynamics, is what is called orbital dynamics. And this is very much related then to space flight, because when you send a spacecraft into space, there are certain kind of equations of motion, let's say, that need to be, that are satisfied. And this is basically based on the types of forces that are acting on the spacecraft. And the only force then, in addition to the propulsive force that is acting, is the force of gravity. And that leads to certain special types of motion. And this you study in orbital mechanics. So what we're seeing here is, so first of all, this blue curve is the orbit of Earth. And then the red one here is the orbit of Mars. Here we have these two orbits that are orbits of two asteroids. And then the green orbit is a comet. So in 2004, there was this mission called Rosetta, where a spacecraft was to go out and meet up with this comet, which is happening right there, right? And so this magenta orbit or trajectory, what it's showing you is what the trajectory was that the spacecraft followed to get to the comet. So what's happening is then that the spacecraft is getting launched at Earth initially, but instead of just going out directly, it comes back to Earth and does what is called a gravity assist maneuver. So right there, you see that it comes back to Earth and then does this, it just basically flies close to Earth. What that does then is that it gives it additional energy. Just by flying by Earth, it gets additional energy that increases the size of its orbit. And then it continues and does a similar flyby of Mars to increase its orbit again, to increase the size of its orbit again, and so on. And so in this way, its orbit kind of increases, the size of its orbit continues to increase, and then it finally is able to reach the comet. So this is the type of stuff that you study in a course called Orbital Mechanics, that where you learn the way in which spacecraft move in space and how you can control that motion. So those were then some of the kind of areas of courses that you take in aerospace engineering. But maybe a good way of getting a sense of what you will be able to do by the time you graduate as a senior, for example, would be to take a look at the aerospace vehicle design course that we have. It's called AAM 4331, and students take this course in the fall of their senior year. So the goal of this course is that there are some projects that you choose from, design projects that you choose from, and then you form teams and work on that design project throughout the semester. The design projects themselves are sponsored by industry partners. So these are very much real life design projects that are of solving current problems that these companies are working on. So examples of past sponsors are Boeing, Honeywell, and NASA, for example. So I'll give you a few examples of the types of design projects from the past. So for example, in 2011, the design project sponsored by Boeing was to create a replacement design for the C-130, which is an airplane that is used by the military. And so it needed this new design needed to match the performance of the C-130 and the versatility of operations, and also being able to operate in unfavorable conditions and so on. But a more modern design, which could be, for example, more fuel efficient, and whatever improvements they could have, the team could come up with. And so here's a design then that the team came up with. So you see some differences that are visible from the outside, that the horizontal stabilizer now is on the top of the vertical stabilizer. There is what is called a canard at the front of the airplane, and so on. So students were able to look at the airplane, analyze its operation, and come up with a new design that hopefully works in a better way. Another example was sponsored by Honeywell in 2017. And this was a navigation and surveillance systems for urban air mobility. That was the name of the project. And so this was basically a system for air taxis that would take off and land on special heliports that could be, for example, on the top of buildings. And students were asked to consider special sensors, communication systems, and so on, and do simulations of the system in operation. Another example, this is actually a yearly competition called Rascal, which is sponsored by NASA. It stands for Revolutionary Aerospace Systems and Concepts Academic Linkage. And so this is a competition for college students that happens every year. So in this case, the goal was to create a reusable vehicle that goes between a cislunar orbiting gateway and the moon. So cislunar orbiting gateway would be a gateway spacecraft that is flying between the moon and Earth. And so the idea was then that spacecraft would be sent from Earth to the gateway, for example, with supplies, but then there would be other spacecraft that would take supplies from the gateway to the moon, and then from the moon back to the gateway. And so there are certain kind of constraints on the design. It was required that the technology readiness would be available by 2028, and then that they that it be consistent with NASA human spacecraft requirements. And so that meant then that these spacecraft would be able to carry people. And then that there are efficient orbit transfers and deliveries. So using all the courses that you would have taken in the third year, the idea would be that you can apply all of that in the designs in the fall of your senior year. So one new thing in the program since 2019 is the co-op program. And this co-op program allows you to gain work experience while maintaining your kind of full-time student status and going to college. And so you would be required to work for 2 semesters, and this could include a summer semester. And while you're working, you would take 2 classes, or you can take 2 classes. Each of these classes is 2 credits. And this allows you to get 4 technical elective credits towards your degree. A total of 9 technical elective credits is required for the degree. So in this way, you can get 4 of those technical elective credits. So this is what the ideal schedule would look like if you wanted to do a co-op. So in the summer after your junior year, you could work in a co-op, and then also work in the fall of your senior year. What that means now is that you would have to make up for this fall semester, which you would make up then in the fall after your senior year. So taking part in the co-op then would add 1 semester to your overall, to the 4 years of your study. Another option is, again, to take the fall classes or to work in the fall, but then to work in the summer after your senior year, but then again, you would have to come back in the fall. So the reason for this schedule is that our department, being one of the smaller departments at CSE, most of our courses in the junior and senior years are only offered once a year. So that means then that if you go out to do a co-op, then it's really the next year that you can take the classes. And especially if those classes are prerequisites for following classes, then it can really mess up your schedule. But so the good thing about these classes in the fall of your senior year is that they're not prerequisites for the classes in the spring of senior year. So that's why this would be the ideal schedule. But if you're ahead in your schedule and so on, it is possible to come up with your own kind of schedule for a co-op. So a little bit about the prospects of job prospects and so on after graduating. So this is from an exit survey, 2018-2019, where 86 students graduated. So about 90% of the students had a job within 6 months. The median salary was $69,000, and about 7 students went on to graduate school. And so this is typical, about 10% of graduating students going on to graduate school. Here are some of the companies that typically hire our graduates, like Honeywell, Collins Aerospace, Northrop Grumman, Raytheon, US Navy, and so on. There are also, so these were kind of typical aerospace engineering companies, but then some students go to related areas. So there was one student who went to 3M, Seagate, Epic, which is a software company. So it doesn't necessarily mean that you always end up working with airplanes, and that's of course perfectly fine. Some job titles: systems engineer, test engineer, even electrical engineer, mechanical engineer. Especially compared to mechanical engineering, what you learn in aerospace engineering isn't really very different, except for the fact that it's mostly kind of focused on aircraft and spacecraft. Like I mentioned, about 10% of our students go on to graduate school, and several actually stay here, but then otherwise go to many different schools around the country, Purdue, Georgia Institute of Technology as an example. So if you need more information, especially about the curriculum, what courses to take, and so on, there's a lot of information on our website, csc.umn.edu/am, and then go to undergraduate handbook. So there's a lot of information for undergraduates there. You can also feel free to email me at katema@aem.umn, sorry, katema@umn.edu. So there will be time for questions after the panel discussion also, but if there are any questions right now for me, I'll be happy to answer those. I think Kaylee was going to.
Oh, one of the attendees asked, what kind of jobs can you get in the Navy?
So the Navy has, I can't really tell you that I know exactly what's going on with the Navy, but they do deal with airplanes in the Navy, right? And so they are in need of engineers. But I know, for example, that some students have gone on to be test pilots, or at least one student I know for sure who went to be a test pilot. And I'm not sure it was in the Navy or the Air Force, but that could be what happened in this case also. So here's another question. Are there any good minors to take with a major in aerospace? So good minors will kind of depend on your interests, but I can tell you that many students go for a minor in computer science because it is an area that is is growing very much currently. And so that could increase your ability to get a job. But then an easy minor to get is a minor in astrophysics. And the reason is that you would only need to take one class to get that minor in astrophysics. So just take one additional class. It's called Astrophysics 2001, and you get a minor in astrophysics. Do aerospace and chemical engineering go well together as a double major? I don't know why you would want to take chemical engineering and aerospace engineering because they're very different. And so I don't think there would be a lot of overlap, which would make it hard in terms of, you know, the amount of time that it would take. But if it's something that you seriously want to kind of consider, we can definitely take a look at it. Are there any other engineering disciplines that work closely with aerospace engineers? So within the workplace, you know, aerospace engineers will generally work with, for example, mechanical engineers, electrical engineers. So it's very much related to all of those different disciplines. So for example, we have a course called instrumentation, where you learn about you know, circuits and how to use microcontrollers and how to connect microcontrollers to sensors and so on, which is typically something that electrical engineers would do. How much extra coursework would the computer science minor be? So the computer science minor requires, I believe, 4 additional classes. But the good thing is that several of these classes count towards your degree in aerospace engineering as technical electives. So it's really not going to be too much of additional work to get that minor. How hard is it to double major in aerospace and astrophysics? Is it possible in 4 years? Well, again, that would depend on the individual, what courses that you have taken already and so on. And that is best maybe to look at, one-on-one. How often are majors employed outside of the defense industry? How can one avoid that industry but stay employable? So there are many civilian, aerospace companies also, like, for example, Boeing and Honeywell and so on. So it's definitely possible to get jobs in those areas as well. What would a typical work day look like? You're working as an engineer, so it depends on the specific area that you're in, whether you're maybe working as a software engineer or a test engineer or whatever it may be. And that's probably what would determine what your work day would look like. So I think at this point, we should stop so that we can let the student panelists discuss their experiences, and then we will have additional time for questions and answers. But thanks for your many questions here. I'll try to get to those after the panelists. So I don't think we talked about who was going to start, but I'll just go in the order that I have on my screen. So Sophia, do you want to go next?
Sure. Let me just share my slides. Can you all see like the full screen slide?
We can.
Perfect. Okay. So hello, everyone. I am Sophia. I'm actually a first year master's student within the aerospace department. I did graduate from the department in just this last spring. So I decided to stick around. I actually double majored in aerospace engineering and Asian and Middle Eastern studies, the Mandarin Chinese track. So I did see a question if there's utility to having a maybe CLA minor. It's definitely something I really enjoyed getting, even though there's not like direct technical skills, but I really enjoyed studying Mandarin Chinese, and I'm really interested in the international relationship side of aerospace. So I thought it was a really good choice for me to double major in that. I did want to mention I did study abroad for a summer in China. You can see some of those pictures on the right. So if anyone has specific questions about studying abroad as an engineering student, I would definitely be willing to answer those. In my time as an undergraduate, I was also involved with the University of Minnesota rocket team. I know Caden will also kind of talk about his experiences there, but that was a really great way to get involved and get to know people in the department, all the other students. I was able to gain a lot of hands-on technical as well as leadership skills. And last year I was the president of the team. I've also been involved with internships at actually a biomedical company and a hydraulics company. So you're definitely not limited to aerospace, nor are you limited to the defense industry. Neither of the, especially the biomedical company, Exact Sciences, was very much not defense related, but I still was able to utilize skills I learned in classes and really apply engineering intuition. And then I also got involved with some departmental research. So actually my senior design project was, it's called HiCube, which is a hypersonic configurable unit ballistic experiment, which is basically going to be like a CubeSat that is purposely deorbited to re-enter the Earth's atmosphere, and it will re-enter at hypersonic speed, which will then collect valuable data to help us understand hypersonic flow. And so I actually started on that as a senior design project. And really enjoyed the project and continued to do some research with the professor that was the PI. And so he's actually the reason why I decided to apply to the graduate program because I got started on a project that I really wanted to see finished. And then I also wanted to talk about like why I like this department here. What I really like is that it's a small department within a big school. So you kind of get the big school vibe where there's always a lot of stuff going on. But when I come into my aerospace engineering classes, I can get really close with my peers and the faculty. And I think it builds a really great sense of community. There's also a lot of diverse research, state-of-the-art equipment and software. And because it's such a small department, it's really nice to have that breadth of research and choices and be able to easily get involved because you're pretty close with your professors. And then of course, student groups. I spent a lot of time on the rocket team as well as the American Institute of Aeronautics and Astronautics. It's a great way to get some technical skills as well as networking and professional development. But yeah, I will not take up too much time, but if you have any questions, you can contact me at my email at the bottom. Yeah. And then was there someone else lined up to go second?
Anna, you want to go next?
Yeah, I can do that. All right. I don't have any slides to share. I was just going to speak, but I'm Anna Bolt. I'm a fourth year aerospace engineering undergraduate student. I do have the minor in astrophysics, and so I can definitely speak to the fact that it's a very easy minor to pick up. I took it sophomore year. I did see a question about the best time to take it, but you do have spots in your schedule if you follow the 4-year plan where you do have opportunities to take technical electives. So I do know classmates that are taking it as seniors. But yeah, again, it's a very nice, convenient minor to pick up. And it also does correspond to a lot of the material you might learn in orbital mechanics. And so I thought it was great to take it as a sophomore and then carrying it through to the junior year coursework helped me a lot. And then that also did lead to an opportunity for me to be a TA in the Astrophysics 1001 over my junior year of classes. So I got to TA for 2 semesters on that, which was on Zoom, but picking up that minor did lead to a lot of good opportunities. I joined aerospace actually because in high school I was interested in Formula One and racing, and I was leaning towards being in the automotive industry. But as of right now, I don't know if I want to work in the automotive industry. The coursework gives a lot of different perspectives, especially the class flight mechanics as a sophomore, really opened my eyes to aircrafts and various other aerospace vehicles and sectors of the aerospace field. I was a marching band member as a freshman, so there's a lot of opportunities to do things outside of aerospace and to kind of get those different perspectives. There are a lot of CSE students in the marching band, and so I think it was a good perspective of the different majors, and speaking to the upperclassmen as a freshman, definitely, and being able to ask them a lot of questions about their coursework and why they stayed in the aerospace department definitely solidified my decision to be an aerospace engineering major. My interest in racing, I joined Formula SAE as a sophomore. I work mostly with structures in that right now, and working with the front wing and the nose cone. The team is now making an IC combustion car and an electric car. So it's an incredible experience if you want to have kind of interdisciplinary work in an out of class engineering setting. So right now I'm looking at working with the impact attenuator and the nose cone, so the very front of the car, modeling that in CAD and working with kind of airflow around that, and then working with the accumulator on the electric car, which is just a giant battery. And so right now we're working with the casing for that and opening it up to work on cooling and fluid flow. And so Formula SAE again is awesome if you're thinking that you maybe want to do aerospace engineering, but you also have interests in computer science, working with the electrical team and coding, or maybe working with engine and being able to kind of dabble in mechanical engineering. That's an incredible student group, and I'm very happy that I joined. Right now on the team, I'm also outside of engineering, CrossFit and Olympic lifting athlete. So lifting, cardio, gymnastics. I've done some distance running over college, and I've actually gotten to use my experiences over COVID. I worked as a personal trainer and a group trainer at my gym in my hometown. And right now I'm training under professional athletes. And I'm getting to use that to start a driver training program. So basically this year we have 2 drivers for the car, and they have to go through a process to train and test other drivers for future cars. And so I'm getting to use that experience to train people now on the Formula SAE team. So it's kind of combining those 2 worlds, which has been great. And it has opened my kind of the door to talking to physical therapists. There's also a lot of biomechanics that goes into sports and into training. And so looking at physical therapy school and whatnot, that kind of connects the biomechanics to maybe what you would learn in dynamics and structures and whatnot. So again, awesome parallels from our industry in aerospace to maybe one in athletics or in racing that would be completely different. I'm also for senior design on the SAE Aero design team. I'm the president and the designer for our team, building a small electric aircraft for a competition. We will get to travel to California in April. And basically the goal is to build a small electric aircraft that can carry a payload through a course and be able to carry it around the track and then unload it. So we'll work with the electric systems, modeling the airfoils, working with structural analysis and whatnot. I'm the president, project manager. I'll help design it, but I've had a great experience as a project manager, which I guess I never thought of until being in that senior design as a potential job in the future. But basically a project manager will just work with making meeting notes, travel budgets. We have master schedules that I follow, precedence networks for getting things modeled and getting like parts budgeted and whatnot. So there's a lot in engineering that's kind of that background work that might not be just modeling or just doing like the physics behind systems. It's also a lot of like the business side of it, which I've really enjoyed. Senior design also is just a great low risk opportunity to try something new, as in us now taking our coursework to build an aircraft, which none of us on my team personally have ever done. So it's a good opportunity to try something, possibly fail, and then be able to restart, which doesn't really happen in a high pressure actual job situation. And with that, I have actually connected with, I did the CSE mentorship program, which was a great way to connect with someone in the industry. I was connected with someone from Boeing, and I'm still speaking with him through this semester. I did the internship as a junior, and he's actually gave really good insights to building our aircraft, possibly working with us for sponsorship money and to connect us with people that can help us design and kind of give insights to what components we should be looking for while building our electric aircraft. And then lastly, I've had 2 great opportunities to TA in the aerospace department. One, as I mentioned before, was for Astrophysics 1001 after I completed the course for my minor. And then I got to TA this summer under Professor Kedema, which was a great experience for deformable body mechanics, which is a course you take over junior year. And structures and materials for me was my favorite part, and the part that I really that really was a strong suit for me over my time in the major. But developing that other knowledge in the coursework has been rewarding, and it's been a great experience this semester, bringing it all together in senior design. But yeah.
Thanks, Anna. Next, shall we go with Kaylee?
Yeah, I can go. All right, can you all see my screen? Can assume yes.
Yes.
All right, so my name is Kaylee Pierce, and I'm also a senior studying aerospace engineering mechanics. I do have the astrophysics minor as well. I took that class sophomore year. I originally came in intending to study chemical engineering, but I realized very early on that I did not enjoy solving chemistry problems, but I really enjoyed physics. I also, similarly to Anna, really wanted to go into the automotive industry. Currently, like after my past experiences, I've realized that I really do enjoy working in emergency management, but I'm pretty much open to working in any industry. I think that like that automotive and emergency management really utilize that kind of systems engineering knowledge and risk mitigation experience that we get in aerospace. Some of the things I really enjoy about our program are the simulation aspects. Almost every class has like a MATLAB physics simulation component. So once you take mathematical modeling and simulation, usually your junior year, you'll know how to do some really, really cool stuff with MATLAB. So real life like physics simulations on rockets and planet movement. And you'll start using that in your courses to see how beams will fail, to see how things move. It's really, really cool. Also, our professors are really cool. I've really enjoyed having all of them. We have one of the smallest class sizes, which makes it a very tight-knit community. I've personally felt like females in aerospace like are usually like a super tight-knit group. Like we all kind of have each other's backs and it's really fun. And then there's a lot of different opportunities. So there's a lot of different job types you can take or you can choose. And the AIAA chapter at the university has a career fair every year. If you look at the photo on the right, that's a photo of me with Spacey Casey at NASA Langley Research Center. I interned at NASA Langley Research Center over the summer. It was a very exciting experience. So it's kind of a little crazy how it happened. My boss, I work at Centennial Hall as a desk assistant, and my boss one day came in and told me that she knew someone who worked at NASA. So I was like, oh, that's cool. And she's like, you should connect with her on LinkedIn and she'll have a meeting with you. And she was actually part of the CSE mentor program as well. But we had that meeting, it went really well. And then she ended up forwarding me application for this job at Langley, which is not where she worked, but I was excited and I applied. And I didn't think anything of it, but then like a month later, they actually like got back to me. And it was the best experience of my life. I got to go out to Virginia for the summer. And the internship that I did was working with wildfire management. So we were working on a UAV system to map wildfires and hotspots to kind of relieve the firefighters doing that job a little bit. I learned so much and I got to meet some really amazing people doing that. Currently, I am involved in senior design, like we're supposed to class-wise, but the senior design project that I chose was the NASA VTOL competition. So we're working to make a VTOL, which stands for vertical takeoff and landing. So kind of like an Osprey, if you all know what that is, to work on wildfires, firefighting. So that's those two experiences are kind of what got me into wanting to work on like the kind of UAV emergency management industry, which is it's kind of hard to get into, or it looks like it's going to be kind of hard for me to find a job there, but I'm trying my best right now. Other activities that I'm involved in here, I'm involved in FSAE, kind of like Anna. I also work on structures. So if you look at the car, all the airfoils or wings have internals in them to keep them from breaking. So I make sure that those are up to par and also make sure the mounts are up to our standards so that nothing breaks, so we don't lose. I'm also on the Science and Engineering Student Board. I'm the mental health coordinator for that. So I do a lot of event planning and such.
Thank you, Kaylee. Caden, you want to go next?
Yeah, sure, of course. Yes, I also have a couple slides that I'll share a little bit later of just some pictures of the student group that I'm active in. But my name is Caden Turner. I am a senior in aerospace engineering and mechanics with a minor in astrophysics. So like you've heard before, yeah, it's a pretty easy minor to get, and you've heard lots of people with that minor here today. In all honesty, it's a bit weird to find people that aren't minoring in astrophysics in the aerospace major. And I've had 2 internships throughout my academic career here. I haven't had any TA experience or stuff like that, but I had internship experience with Carrier in Indianapolis. So that was like HVAC, so like furnaces for residential homes. And then this past summer, I interned with Donaldson in Bloomington, which was sort of simulation and modeling of filtration technology. So you see a couple examples there of non-aerospace related work that you can find even with an aerospace major. And so, I would encourage people to know that, you're not locked into aerospace related jobs just because you have an aerospace major. And, you still learn a lot of valuable experience that way. And like Sophia was saying, she was the former president of the rocket team. I am the current president of the rocket team. And so I'm very heavily involved there. And I just want to share a couple pictures when I talk about the rocket team a little bit here. The rocket team really provides a really great experience for students, and it's a club that operates through the department here. So we have lab space here that's given to us by the department, and we have a faculty advisor who works closely with us to ensure that we understand what's going on and helping us with competitions and stuff like that. And so here you see a picture of quite a few students in the club holding up our large competition rocket, which we launched just this last summer. But more importantly, what I want to talk about is some more opportunities that you get through extracurriculars like the Rocket Club. And so just in early September here, September 4th, we actually went down to Southern California to launch our high altitude rocket, which unfortunately had a structural failure in flight. However, that was still a really awesome learning experience and something that you wouldn't typically see. I don't know if I want to say that it's a once in a lifetime experience like that, but it was really one of the highlights of my career, or not my career, but my time here at the University of Minnesota so far, especially because of the COVID pandemic and everything. Just being able to get out and really bond with different people, especially in the aerospace engineering major, and other students as well, was really awesome. I really encourage people to join engineering clubs because you really get that engineering experience that you wouldn't get by just doing your academics otherwise. And this isn't something that's unique to Rocket Team. I'm just using the Rocket Team here because it's something that I do, and it's provided through it operates through the aerospace department. But really any engineering club, you get engineering experience, you can get leadership experience, manufacturing experience. We do machining, lots of other teams do machining and working with composites and stuff like that. And so, I definitely feel like my experience through the Rocket Team has really helped me land my internships that I got. And I think it really provides you a leg up compared to people that don't do it. So yeah, again, I'm going to try and keep mine short here for time, just because we want to get to questions for the panelists. As far as things that I liked about the department as well, I just want to piggyback off of what some of the previous panelists have said about how it is a small department. And so you really do get to know your professors, especially when you start getting up into the, tech electives and stuff where your class size really starts to dwindle down to, 10 to 20 people. The professors, you get to know them, and they're all really nice and really willing to talk to you, and they really seem to care about your education. And so that's something that I've really enjoyed here at the university. Part of the reason why I chose, the aerospace major here was because of my interest in aerospace, but also because of the opportunities that such an university provides. And the fact that it is a small department in a large university is something really unique that I don't think you see at other colleges, that provides sort of a tight-knit community, like everyone has said, where you feel close to people, but then you have all the opportunities of a large university, like the Rocket Team, or like Solar Vehicle Project, like SAE, Formula SAE, where you get all these opportunities to learn different skills that are really applicable in the industry. And so, yeah, with that, I think that's all I'm going to share, just so we can, again, get to questions for panelists.
So if you have any questions for the panelists or for myself, please feel free to use the Q&A. So one question here is the rocket team still open for people to join? I guess Caden.
Yes, it's still open to join. You can join any engineering club at any time, whether that's rocket team, SVP, your solar vehicle project, Formula SAE. Just reach out to them. All the teams have websites, as far as I know. I don't know, Anna, does Formula SAE have their own website? But rocket team, we have our own website. If you just look up UMN rocket team and go to like a join tab, you can sort of email us and show us your interest. And something that I really encourage people to at least see if they're interested in and explore.
Here's another question. Are AIAA and the rocket team the only AEM related clubs?
I guess I'll take this one. I would say yes, as in the fact that they're sort of operated through the AEM department. So, every student club sort of needs a faculty advisor and sort of a department that they operate through. And so the AIAA and rocket team do that through the AEM department. And that's not to say that you can't learn valuable skills outside of those two clubs that would be applicable to the aerospace field. I don't know if anyone else wants to chime in on that, like Sophia, you were really involved in AIAA as well. And Kaylee, I don't know if you have something, but.
Oh yeah, I was just gonna say, there are a couple other small student groups. There's one called Small Sat. I know Dr. Flotten has a couple groups. I think he has a ballooning one and another CanSat group. Also, sometimes senior design groups will like recruit younger members if you're looking to get into project group. So yeah, and additionally, on our formula team, and I believe on Solar Car as well, they do have aerodynamic sub teams. So there are like spaces specifically for aerospace engineers in those clubs as well.
Yeah, I know there's quite a few people in the department that participate in the solar vehicle project. So not necessarily planes, but still utilizing a lot of your school, like your skills that you learn in class. And additionally, I think as the department has kind of grown a little bit, there's a lot of opportunities to get involved with research labs. So if you really like one of your professors or you just think they're cool, I definitely recommend like reaching out and just talking to them and seeing what sort of opportunities they have, because I know one professor for sure, he kind of has like his own little group and they do a lot of cool things together, and there's grad students up to PhD, but there's also a lot of undergraduates and they're all doing really cool things.
What is something that you wish you knew when going into AEM? Maybe something that surprised you, or maybe something that you were not ready for, maybe, or something. I'm not sure what the.
I guess I can chime in a little bit on this. I mean, something that surprised me was just, I guess I didn't really know beforehand how small the AEM department was, especially compared to the university. So I just thought, oh, it's a large university. The AEM department's probably really large. SpaceX is really hot right now. Other space race, sort of stuff is going on. I thought, aerospace would be a really big department, and it's something that I was a little bit surprised about, to find that it was smaller. But it's something that I think has ended up being beneficial, again, with being able to meet, know pretty much everyone that's in my sort of year of aerospace engineers, and be able to get to know my professors more as well.
I think for me, it's just kind of like how easy it is to get involved with things like research, like especially as I'm going into my graduate degree and doing research. I kind of wish I had done more as an undergraduate, just because I feel like some of the people around me started doing it really early. So I might be lacking in some of those skills, like presentation skills that they have, or like experience publishing papers for conferences. So for me, it was more like how easy it is to get involved with that side of the department.
Yeah, I guess I would say something that I wish I would have known is I wish that I would have reached out to my professors more freshman year, because all the professors here like want to help you, and if you are doing stuff on the side of school too, like they want to help you with that as well. So I wish I would have like asked them for help with formula. Currently for senior design, I reached out to one of our professors to see if she would help with equations. Before senior design, I reached out to Professor Reagan, and I wanted to do this project really badly. And I sent him the project link, and he was like, yeah, sure, we'll add it to the list. So they all want to help you, and they want to help you like pursue your passions as well.
I definitely
Thank you.
think just, yeah, a quick like side note to professors wanting to help you too. I do think there's a lot of value in doing the student groups that the four of us have mentioned, and even branching out into some of them that might even be more mechanical engineering based if you find yourself more interested in something, just because that does give you a lot of experience pre-senior design working with SolidWorks and flow simulations and getting to actually apply the coursework to programs that you'll see in internships or in jobs after college.
So next question was, what was the average internship application yield, i.e. how many internship acceptances versus how many applications sent out? I don't have any specific numbers for AEM, especially not for this past year. But what I know is that in the year 2020, 2019, 2020, 46% of CSE students did at least one internship. And I wouldn't think that AEM's numbers are very different from that. So, about half the students will at least do one internship successfully. We have one last question. How much of a workload do these clubs add to a typical daily schedule? Kaylee, I think you want to answer that.
Sure. So our team for comp, or if you want to go to the competition, we always say 12 hours a week minimum. So I know people on the team who probably put in 40 hours. I know people on the team who probably put in 5 hours, and it's really flexible. These teams are usually really flexible to your schedule as long as you're willing to communicate. I don't know how Rocket Team functions, but as long as you're willing to communicate, oh, hey, I have a big project due this week, I can't put in as much time, like we're still happy to have you on the teams.
Yeah, I mean, it's pretty similar with Rocket Team as well. You can put in as much or as little time as you want. If you want to go to the competitions and travel with us, typically we bring 20 to 30 people down to New Mexico every year. And if you want to do that, then you need to be, pretty involved on the team. It's the same thing here, where I know people that maybe just attend meetings every once in a while on the team, and I know people that put in 40 hours of work a week. If you're like me, you're sort of like a fanatic, and it basically becomes your life, which is where the point that I'm at, like I said. But that's not something that's typical that you see with students, and it's not something that we as a club, we don't expect people to be putting in 30 hours a week. And again, it's all up to you how much time you want to put in, and really it's just what you put in is what you get out, right? If you want lots of experience and a lot of stuff to talk about on your resume, then really dive in and doing as much as you can on the team is really going to help you with that.
All right, I think we're out of time. And thank you all for taking part in this session, and especially thank you panelists for being willing to join us here. Thank you.